Hello beautiful people and welcome. In today's video we are going to go through the answer key for our chapter 6 quiz. Now if you are in my class and you are choosing to retake this quiz, please make sure that you write down and redo all of your questions as part of your quiz corrections. Alright, let's go ahead and start. The first questions are asking us to identify the following exponential function as growth, exponential decay, or neither. So when you are determining a growth, decay, or neither in an exponential function, you're going to take a look at this b value. This b value tells you if it's going to be a growth, decay, or neither. Now what you're going to do is you're going to also take a look at the a value. So this B and this A have a relationship. If the A value is negative, then we have a neither. And this is because we see a negative. If, however, we do not see a negative, that means neither cannot be our answer. It's going to be a growth or a decay. So since our A value is positive, we are only looking at the B value, the highlighted in pink. And so the value of it, since our B value is a fraction, this is going to be a decay. Since our B value is bigger than 1, this is going to be our growth. Question number 2, identify the asymptote in the following function. So for asymptotes, you are going to be looking at the K value. The K value is located at the end of your equation as an addition or a subtraction. So when you write your asymptote, you have to write it as an equation of y equals. So for us, we have y equals 8 and y equals 7. Now notice here, we do not have a k value. The only thing I see is a -2, but that's in the exponent spot. So this is a missing k. And since we have a missing k, k is 0. Next step, it's asking us to describe the transformations. When you are describing transformations, you want to take every single thing and tell the reader what each section will represent. So I'm going to draw a little arrow here. So a negative represents a reflection across the x-axis. The 4 represents a vertical stretch because it's bigger than 1. And we are saying by 4, we don't just want to say vertical stretch, we always want to mention how far we are stretching. Next, I'm taking a look at my B value, and our B value, like we saw in example number 1, is dependent on our A. So since we have an 8, technically it could be a growth, but because we have a negative, we have a neither. So it's neither growth nor decay. The H value is always opposite of what we see. So if we see a +3, that means we have a -3 and we go left 3 shifts or 3 jumps. The K value is for keep. So I'm going to see a +4. That means I have a +4. So that means I'm going to go up 4. For questions number 4, there's 2 questions here, A and B. Does the table represent an exponential function? State your reasoning. So an exponential function has a common ratio. So I'm going to rewrite both of these. So that way I can label my right and my left better. So we get 0, 1, 2, 3. 1, 2, 3. I got 32, 28, 24, 20. So when I do my right divided by my left, I got 28 and 32, 24 and 28, and 20 and 24. If this gives me a common ratio, then yes, this is exponential. If it does not give me a common ratio, then no, this is not exponential. 28 divided by 32, repeat after me. Decimals are not allowed. You cannot write decimals. Convert that into a fraction. 24 over 28, decimals are not allowed. Convert that into a fraction. Repeat after me. Decimals are not allowed. So if you take a look here, all of our ratios are different. So this is no, not exponential. And how do we know? No common ratio. Do the same thing for this one. And the reason I'm rewriting it is because for me it's easier to do a right over our left. Now notice the difference between here, 0, 1, 2, 3, 5 goes to 10, 10 goes to 15, 15 goes to 20. As long as there's a pattern, you're fine. We have 8 over 2, 32 over 8, 128, and 32. I got a 4 for the first one. 32 divided by 8 is a 4. 128 divided by 32 is still a 4. So this one is yes, exponential. How do we know? Common ratio is 4. Now you can write the word common ratio, but little r is the word common ratio. So you can just write this. Okay, moving on to the back side. Question number 5 is asking you to graph. This is the type of questions that you are technically not allowed to use a calculator. So on our quiz, you had access to a calculator. Some of you decided to use a calculator. Remember, you are not allowed to use a calculator on questions like this. All of this needs to be done by hand. So we have copy down the function, but anytime you see x, you're going to input your x value. Copy down the function. Anytime you see x, you input your x value. Oops, that should be a -2. Copy down your function. Anytime you see an x, you copy down the x function. Now here we only had an x in the exponent spot, so our x gets added with a 1. So we get 1/2. -3 plus 1 is -2. -2 plus 1 is -1. Again, notice I'm not touching a calculator. You cannot touch a calculator with questions like these. What we are testing you is 2 things. First thing is, do you know how to deal with a negative exponent? I see a negative. That means I flip my base. Then exponent becomes positive. Next, what I test you on is, do you know how to work with exponents? This is 2 times 2. This is just 2. Anything to the 0 power is 1. This is just 1/2 once. And this is 1/2 twice. Next, we have multiplication. 2 times 2 is 4. This is just 2. This is just 1. This is just 1/2. 2 times 2 is 4. 1 times 1 is 1. What is the asymptote? Again, we're looking at our k value. K here is missing, so our asymptote is y equals 0. If you don't write y equals, points will be deducted. The domain, I don't even need to look at the function. Domain is always going to be from -infinity to positive infinity. But for our range, we need to graph it, okay? Range is going to depend on your asymptote. So let's start with our asymptote here at 0. Remember, draw your asymptotes with arrows because they are continuing to the left and to the right. Next, you are going to be graphing these following points. You got -3, 4, -2, 2, -1, 1, 0, 1/2, and 1, 1/4. -3 and 4, -2 and 2, -1 and 1, 0 and 1/2, and 1/4. Connect. Now here's the thing. You're going to extend out because this is exponentially going up this way. And then we are decreasing half an arrow here. Do not touch that asymptote. It's a big no-no. This is going to be a decay function because we're going downhill. Now, for our range, we're looking at the minimum value. What's the smallest it can be on the y-axis? Again, for our range, we are looking on our y values. So it looks like we're going up, 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 up all the way. So we are increasing our y values, but we are also going downhill as a decaying function. And it looks like 0 is the smallest number we are approaching here. So that means 0, infinity is our range. Flipping it over. Another one again. This one, you're still not supposed to use a calculator, but because we are giving you things like a -10 with fractions, I can show you how to use the calculator without technically using the calculator. All right, again, open up your function. Where you have x, you're going to do your input. So for us, our input here is -2. This -10, I'm going to be a little extra and draw it a little bit larger so I don't think it's an exponent. So 0, 1, 2. Again, what are we testing you? We are testing you. Do you know what it means to have a negative exponent? Do you know what it means to have a negative exponent? Do you know what it means to have anything to the 0 power? Do you know what it means to have an exponent? So here we still have that 1/5 times 1/5 twice. 1/5 once because the exponent is 1. And so now here we got 1 minus 10, which is a -9. We got 5 minus 10, which is a -5. Here we got 25 minus 10, which is a +15. Now, this one here, there is some space down below, which I am going to ask you to work on. We have 1/5 minus 10. We need to convert that to common denominator. So I'm going to multiply top and bottom by 5. We have 1/5 minus 50 over 5, which is a -49 fifths. Now the next one, we first have to do 5 times 5, which is 25. So I'll rewrite that here. So we have 1/25 minus 10, again, common denominators. So this is where I mean to say, we're not using a calculators, but if something comes up like 25 times 10 and you're not sure what that is, obviously use a calculator. You have access to it, but I need to see all of this work done by hand. And again, 1 minus 250, you can do that on a calculator. But things like 249 negative over 25 is not something that we're going to be graphing per se. And I'll show you what I mean by that here. So our points are 0. Oh, actually, back up a little bit. What's our asymptote? Our asymptote is at -10, so we got y equals -10. I'm not looking at my domain because I already know what it is. For an exponential, it's always going to be the same. I'm going to wait on the range because range depends on your y values. So let's graph our asymptote first at -10. So we are all the way down at the bottom here. And then we have 0 and -9, 1 and negative 5. 2 and 15, I don't have space for that. That might be somewhere here. And then we have, let's go back at negative 1. So I don't know what that is, right? Let's go ahead and type that into the calculator and see. It's about a negative 9.8. So almost at a negative 10. But again, our asymptote is at negative 10, so we cannot touch negative 10. Extend out, bring that forward, arrow, and you have exponential growth. So what's the smallest number we can have? Negative 10, and we go all the way up to a positive infinity. Next one, it says determine whether the table represents a growth function, exponential growth, exponential decay, or neither. Some of you lost points here because you just told me yes, it is exponential, or no, it's not exponential. Actually, not what it's asking. Is it a growth? Is it a decay? Or is it neither? If it's not an exponential, it's neither. It's not exponential. So let's go ahead and do our exponential test. Our right divided by our left. 10 over 5, 20 over 10, 40 over 20. So we have 10 divided by 5 is 2, 20 and 10, that's 2, 40 and 20, that's 2. So that means our common ratio is 2. Again, what is it asking? Is it asking for exponential growth, decay, or neither? Since this right here is bigger than 1, our common ratio is bigger than 1. This is exponential growth. Again, the reasoning for that is because the value of the common ratio is bigger than 1. I'm going to flip this table on its side. So we got 35, 29, 23, 17. We got 29 over 35, 23 over 29, and 17 over 23. Divide, see what we get. 29 divided by 35, no decimals. Looks like that fraction stayed the same. I have a feeling, my feeling is correct, that these fractions are going to stay the same. I was looking at numbers and I'm like, I think these are prime numbers, so primes cannot be simplified. Are these the same ratio? These are different. No common ratio. So is it exponential growth, exponential decay, or neither? It's a neither. It's not even exponential. So again, not exponential is not what it's asking. It's asking, is it growth, decay, or neither? So it's neither. Moving on. A pond has 650 fish. The population decreases, this is important, decreases by 2.6% each day. Write a function to represent the number of fish after X number of days have passed. Okay, this is a growth versus a decay. Since we are decreasing, we have a decaying function. So we have y equals our initial amount, 650, times 1 minus. Okay, now let's go ahead and convert that decimal percent into just a decimal. So since we have 2.6, I'm going to shift this decimal 2 jumps to the left. So what we have is 0.026. And now what it's asking of us is asking us for X number of days. So that means the time that we typically would have here, would be X. Now I did accept an answer like this. There's absolutely nothing wrong with that, but we do want to simplify. So I'm going to subtract 1 minus 0.026 on a calculator. And so technically our equation for our decaying function would look something like this. But if you gave me the unsimplified version, I did accept that on the quiz. Find the population after 7 days. So I'm going to take either one, it doesn't matter. If you use the unsimplified, then use the unsimplified. We want to do the caret, and then for the exponent of 7, Now be careful here. You are wanting to round to the nearest whole fish, right? There's not like a tail just swimming by itself. So we have 541 because this is a 5. We're going to be rounding up fish. Next one. Emma has $500 in her savings. Her balance account will increase. Increase means growth. 13%. So 13%, let's convert that by taking and putting a decimal place at the end. Since we don't have one, 1, 2. So that means we have 0.13 as our rate. So we have y equals, what's her starting amount? $500. We have a growth function, so we're adding 0.13 is her rate. And we want X months, so X goes into a month. Again, if you gave me this answer, I accepted that answer. But technically, you do want to add 1 plus 0.13 together for 1.13 X as our simplified function. If no other deposits or withdrawals are made, how much will be in the account after 2 years? Be careful about this. When they initially gave us the rate, it was given to us in months. But now they're asking us for 2 years later. So that means your X is in months. You can also say your time is in months. So that means 2 years is 24 months. So when we take our equation, let's take the unsimplified. I saw that more frequent on the test. You would not put in 2, you would put in 24 for your exponent. Let's do that on our calculators together. 500, open 1 plus 0.13, close, caret 24 months equals. Okay, so we're talking about money. Oops. Oh, no, that's right. I thought I wrote it in the wrong place. Money needs a dollar symbol for us. 900, just kidding. This is $9,394 and 0. Now be careful. Money has 2 decimal places, so I need these 2 decimal places. Oop, can't see. But if we take a look at the next one, this is a 5. That means my number in front, this 4, will be rounded up to 5. Okay, moving on. Last question here. Write a function that represents the balance. $3,000 deposit that earns a 1.4 annual interest compounded monthly. Okay, let's slow down. Immediately here, this word compounded means we're going to be using the compounded formula. Compounded is followed by monthly. Since we have an annual means a year, yearly, and we are going to be calculating monthly, so a certain times a month each year. So if I'm calculating every month, how many times a year am I calculating? This is your N value. And since we're saying 1 year annually, 12 months are in 1 year. So our formula, you can say Y or you can say A for our formula. Our original starting amount is 3,000, our principal, times 1 plus, okay, what's our rate? Convert it. 0. Let me back up just slightly. We have 1.4%. So shift it 1, 2 jumps to the left. We get 0.014. Our N value is 12. And then in the parentheses for your exponent, we got our N times T. Okay, so this right here is your formula for the compounded monthly example. If no other deposit withdrawals are made, calculate the amount money soon after 5 years. Okay, so unlike example number 9 or question number 9, they gave us months and years. Here, they are giving us years and years. So all we do is take our formula, and I'm going to write parentheses around here, caret, and then instead of T, we're going to do a 5 for 5 years. Now, I put parentheses around this right here because when you type it into the calculator, it needs separate parentheses. Practice with me, please. So you have 3,000, open, 1 plus open, 0.014 divided by 12. Be careful. Close it. Close it again. Caret, open, 12 times 5, close it, enter. Now again, what are we talking about? We're talking about money. Money has a dollar symbol and is rounded to 2 decimal places. After 9, I see a 3. 3 means we keep the 9. All right, beautiful people, thank you so much for watching. If you are choosing to retake your quiz, go ahead and continue working on your practice with the required worksheet, in addition to correcting your answers from the quiz. Have a great rest of your day. Take care.